Okay, so rule-based, as we said, that it looks like rules, right? you're extracting rules from your data, where it looks like if, then, like you do in any programming language. But the rule is the condition that you're looking for, right? So rule-based classifier, or rule-based in general, where you extract your rules from your data set. Then based on these rules, now you were able to write if, then, for example. Okay, but the rules are not at your hand first. You need to extract them from your data set. One of the example that can help you to extract rules is decision tree. So decision tree we already studied, right? So decision tree is very helpful to extract rules from your data set. Okay, so here is an example. If blood type is warm, lay eggs, yes, then this species is bird. If taxable income is less than 50K, and refund yes, then evade equal no. Simply like as you write your if condition. So we already discussed about these. I don't want to go back again, unless if you have a question, by all means. So these are the rules, the metrics that we can evaluate our rules using coverage and accuracy. Okay, I think I stopped here. Yeah, I think correct me if I'm mistaken. I think I stopped here. So rules here, let's say we have such rule list, R1, R2, R stands for rule. And then this is our, let's say, some records we would like to predict what is the type of species we have. So how we can use this rule, the rule set that we have in order to come up with our final prediction. So we go starting with R1, we need to check, or we take the record, one, warm, where blood type is warm, give birth, yes, can fly, no, live in water, no. And then we go and see which rule can be triggered by this record, meaning which rule can make satisfaction. That means if you write if then if is true, then you can lead to the final prediction. Okay, so we start with this one. We go for rule one. Rule one requires only for the condition gives birth and can fly. Then we check. Give birth should be no, can fly yes. Then we check against blood type, not blood type, just give birth is no, right? I wish I have my. So here, since give birth is yes, while here give birth is no, right? So this instance or this record cannot trigger rule one. How about rule two? So rule two says give birth no, while this one give birth yes. So also cannot. How about rule three? Rule three says give birth yes, and our record yes. Then how about blood type? Blood type is warm, and also the rule says blood type warm, right? Then in that case, this is mammal. Clear? So you need to check the rule. Sorry, you need to check the record against your rule. See which rule is satisfied. Actually, this is like just if then, meaning if give birth equal no and can fly yes. Now else if give birth no and live water yes, then that means fish. Else if give birth yes, blood type warm, then it's mammal. Else if give birth no, can fly no, then it's reptile. Else if live in water sometimes, then it's type of creature. So the point is you have else if all the time. So each rule represents one if condition. Now for the second one, the turtle. So the turtle, we need to check which rule or which condition is going to be satisfied or triggered. So we have for rule one requires give birth, no, can fly, yes. So give birth, no, yes. There's one match. How about can fly? Yes, no, then cannot trigger rule one. How about triggering rule two? Give birth, no, also this is no. Live in water, yes, here sometimes. then also cannot trigger rule 2. Rule 3 also cannot. Rule 4, yes, because give birth is no. Can fly, no. Then it's reptile, right? But also it can trigger rule 5. Rule 5 says lives in water sometimes. So now we have mismatch, or like we are confused. Which one? That's fine, but at least now we know that this record can trigger rule 4 and rule 5, and same for the rest. Now there are characteristics for the rules. I should make it wireless. Okay, now there are two characteristics for the rules. We have mutually exclusive and exhaustive rules. What do we mean if we call such rule list is mutually exclusive? Mutually exclusive means every record is covered by at most one rule. That means inside your data, you take the record must find at least one rule to trigger. Right? So it says, sorry, at most, not at least, at most one rule to trigger. If that is the case, then we can say these rules we have, the rule list or the rule set is mutually exclusive. Okay, this is the first characteristic. The second characteristic, exhaustive, means every record is covered by at least one rule. So we have the records inside our data set. At least there is one rule can be triggered by this record. By any record we have, at least there is one rule. So if we check back our case now we discussed. So this one, is it mutually exclusive? Mutually exclusive. Remember, mutually exclusive means the record must trigger at most one rule. Now, if you check Turtle, Turtle can trigger our rule 4 and rule 5, correct? Not at most, more than one. That means it's not mutually exclusive, this rule set. Is it exhaustive? No, because if you check Dogfish has no rule to trigger. There is no rule to trigger for the case of Dogfish, meaning we cannot predict. So this rule set from R1 to R5, the one that we have, they are neither mutually exclusive, sorry, nor and neither or nor. Neither mutually exclusive nor exhaustive. Clear? So there's no characteristic, I mean, none of these characteristics applied to this rule set. Now, what we need to do in this case, if our rules are not mutually exclusive, is it the end of the world? No. So what we need to do, there are two solutions. Either we go and order our rule set from, let's say, the most important rule to the least, maybe based on the accuracy. Remember the one we just now discussed, we calculate coverage and accuracy. Maybe based on accuracy, we sort out our rules. The one that shows higher accuracy, we put it at the top, followed by the lower, followed by the lower, followed by the lower. Then in this case, what we do, the first rule, the record triggers, that's it. We take it. So back to our case, where the Turtle has triggered R4 and R5. If it's ordered, just we take R4. The first rule set is being triggered, like an if-else when you do in programming, right? Just you satisfy one, the first one met, that's it. So this is how mutually exclusive. If they are unordered, then we apply some voting scheme. Voting scheme like, for example, see the majority rules, what do they say? The triggered majority rules, what do they say? They say reptiles, then reptiles, if it's unordered. Now, if the rules are not exhaustive, no problem, very easy. Just we can add a default class, like in if then, if else, just you have the last one else, right? If you remember if then condition. So meaning if none of the rules can be triggered while you are applying if then condition in any programming language, then you have the last one says else. I mean, anything else should go to the last one. Same idea. So we define a default rule. Like this example here, the default rule meaning empty antecedent. There is no condition. Same like in if then in programming language. You don't put else if, just else. Empty, there's no condition. Then whatever should lead to some class. YD. YD means the class we are looking for. Now, what is YD? The majority. Let's say if the majority of my data set showing most of the cases are reptiles, then if I cannot determine whether this is bird or fish or whatever, then just I say, okay, else it's reptile, because the majority of the cases inside my data set for reptiles. Okay, clear? Any question? So this will help to solve exhaustive rule set and for mutually exclusive. So as we said, we have two types of rule set. We have ordered or unordered. So for ordered rule set, we can use ordering. There are different ordering scheme, rule-based ordering scheme or class-based ordering scheme. But for unordered, we can use hard voting or soft voting. So what do we mean by ordered rule set? Let's take a look. So for ordered rule set, as we said, probably we take some, we calculate the priority. Which rule is have highest priority? For example, we take accuracy. We calculate accuracy for each rule. Then based on accuracy, coverage and accuracy, let's say, then we decide which rule has the highest priority. We put it at the top. So just we sort them in decreasing order. The most important one at the top, followed by the least important, followed by the less important, less than the least important. Okay, clear? This is for ordered rule set. Now for ordered rule set, in this case, as we said, the case for turtle can be solved because turtle can trigger R4 and R5. If our rule set is ordered, just we take the first rule, the first triggered rule. So in this case, R4 says it's reptile, right? While the fifth rule says this is amphibians. Then, since this is ordered, we take the first rule, R4, triggered before R5. Since it's in the ordering scheme, then R4 is more important than R5. Then we take reptiles. Okay. Now for rule ordering scheme, meaning how do we order when we calculate? Now accuracy, if you remember, accuracy take what? Take the antecedent and the consequent, both parts, right? The accuracy, if you refer back to the slide. So you can decide whether you are going to depend on the antecedent to sort your rules or based on the class base. Like for example here, if you notice, probably I don't have the laser. So if you notice here, we are looking for the rule base, meaning if you check here, the classes might be in different positions. So here we have binary classification where the result either yes or no. And then the rules based, let's say on accuracy, we find out which one is most important. We put it at the top, followed by the less important, followed by the less important, and so on. Now for class based, no, we go and check. You see, we're gonna sort out those, let's say, classes. Okay, while class based ordering, meaning we look, for example, probably we take the majority. So the majority maybe belong to class no, then we order them. So we have separate. I already put no, but still. Now even faster. You see many slides are hidden, huh? Duration, after, advanced slide, after. But still, okay, no need for after at all. Yeah, makes sense. Okay, so here you notice that all the rules belong to the class no comes first, then the rules for class yes come next, because we're looking for the class rule-based scheme. Okay, and now for rule-based ordering, as we said, based on their quality, probably you're taking accuracy. So what you do first, rules that predict the same class are grouped together into the same subset, as you saw. So all the rules for class no and all the rules for class yes, right? Then what we do, we calculate some submetric where it didn't describe or we didn't come across this course, I mean this course, total description length. So no worry, just based on some metrics, we calculate for each subset. Okay, for each rule first, and then we take for each subset. the classes that are arranged in decreasing order for their total description length. Anyway, since we didn't come across total description length, so you can just, this is for your information. Don't need to worry much about it. Okay, so when we come, in this case, since we have rule set, then when a test instance is presented, it will be classified by the highest ranked rule that covers the instance. Like the case of Turtle has triggered R4 and R5. Then R4 is more important. Assuming this rule set has already been ordered, then we take R4. Okay. This avoids the problem of not mutually exclusive. Now, unordered rule set, we have two types, hard voting and soft voting. Hard voting means I look for each rule. Each rule has the same weight of voting. Like the case, let's say if you are going to election, I mentioned this before, then each one of you carry the same weight, the same power, right? So after all, they're just going to count how many people have voted for one elected person versus the other and take the majority. Same like we live in our life, daily life. Soft voting, no, we give some weight to the rule that maybe has higher accuracy, has higher voting power. Okay, similar like what we have done in KNN. Same idea. We have hard voting, soft voting. Now for rule extraction method, simply there are two ways, either direct method, where we go directly to the data set and extract rules, or we have indirect method. Indirect method means we need to depend on like decision tree, for example. So instead of going directly to extract rules, we need first to build decision tree. Only then we can extract rules from decision tree. So this way is called indirect, because you need first to go and build decision tree. After decision tree is built, fully ready, then you go extract rules from decision tree. While direct, no, there's no decision tree. You need to go straight away to the data, apply some algorithms to extract the rules from the data set. Clear? I'm not going to talk about direct method. Actually, I explained last semester it was included, but decided to take away. So I'm not going to cover this section. But if you are interested, let me know. I can give you some references to refer back. Now for indirect, this is an example for indirect. If you remember the iris data set, we have betel length, betel width. So let's say this is our decision tree. We came across. Now we can extract rules. So notice how the rules look like based on the decision tree we have. Now, if the betel length is, notice here, whether it's greater than 1.9 or lesser or equal to 1.9. So we write betel length if it's less than or equal to 1.9, then this is leaf node. Remember decision tree, this is leaf node, and the class for this leaf node is iris setosa. So we say this is iris setosa. Now, else if, so now you can think, or if, because we didn't order the rules, so let it just be if then. If betel length is greater than 1.9 and betel width is less than or equal 1.7, then it's iris versicolor. Finally, if betel length is greater than 1.9 and betel width is greater than 1.7, then it's iris virginica. So you see, we need to use decision tree after it's being built, then we can extract rules. This is interesting, right? If you are working on case and you would like to have rules in hand, then decision tree can help you, because decision tree easy to interpret. If you remember the advantages, easy to interpret. How to interpret? Like now, we extract rules from the decision tree. Now, later, if I got iris setosa, I know why. Because that means betel length was less than or equal 1.9. Okay? Good. This is an exercise showing you how we can figure out how we can calculate accuracy coverage and how we can check whether this rule set is mutually exclusive, exhaustive, or not. So assuming we have this data set, 10 records only, And we are interested, and these are our rule set. We have R1, R2, R3, R4. So already the rules been given to you along with data set. Now the question is like follow. Is rule set mutually exclusive or not? Why? Provide cases to support. Then we need to take the rule. We have the rules on our side, 1 to 4, and go check. In order to be mutually exclusive, what is the condition? Says that the record must trigger at most one rule. So just go and check. If you find this is correct, then it's mutually exclusive. If you can find at least one record which can trigger more than one rule, then it's not mutually exclusive. End of the story. That's it. This is how you answer this question. This was in the replacement exam of last semester. Yeah, so record 1 triggers rule. If you notice why it's not mutually exclusive, record 1 triggers rule 1 and 3. Also, as supporting example, another one, record 5 triggers rule 2 and 3. Since a record can trigger more than one rule, then it's not mutually exclusive. That's it. Question 2, is the rule set exhaustive? Now, in order to be exhaustive, every record is covered by at least one rule. That means if you can find a single record that cannot trigger any rule, then it's not exhaustive. Otherwise, it's exhaustive. Okay, so now if we check back, we're gonna find that record 3 has no rule to trigger. Has no rule to trigger. If you write if then, cannot satisfy any of if then condition, then it's not exhaustive as well. That's it. You see how easy? Compute the coverage and accuracy. So just we got example earlier, we can refer to how we calculated coverage, and only for rule 1 and 2, not for all rules, just for rule 1 and 2. So we take rule 1 and then we calculate the coverage. We check, we find that only 2 records match the rule out of total 10. Then the coverage is going to be 2 divided by 10, 0.2. That means this rule covered 20% only of our data set. The accuracy, 2 records are correctly classified out of the 2 covered record. Then the accuracy is going to be 100%. Right? And same for rule 2. Same for rule 2. How can ordered rule set help to solve non-mutually exclusive? As we said, we can order our rule set in descending order based on their quality. For example, after we calculate accuracy, then we sort them out in descending order. That's it. Then the record, that the rule that is triggered first, that's it. We take the result or the consequent as our final prediction. What can we do to ensure the rule set is exhaustive? Just by adding what? Empty antecedent, else, like in if-then condition. The last one, you need to add else to make sure that it's exhausted. So in case if you have record cannot be triggered by any if else, then there's the last one, else can be triggered. All right, that's it. Any question? Yeah, I didn't want to spend too much time on this because decision tree, I like it more interesting. Once you built it in the direct way, you get the rules, that's it. The direct method, I'm not going to cover. If you like, again, if you like to study more, then you can ask me. I'm going to pass you some materials if you like, but it's not included. Okay. Anything I don't cover is not included. Any question? Okay, no question. Then we go to the next concept.